Hello everyone, and welcome back to my RC plane series. This is part 2 of the series where I'm going to explain how I designed the fuselage, connected it with the wings, and the current electronics I have and wiring for the plane in the future. If you haven't already, go and check out my first video where I explain the science behind aerodynamic lift, flight, and how I designed the wings of my plane. I designed the fuselage based on a commercial fuselage, which looks like this, where it is circular and uniform throughout, other than at the nose and tail where the fuselage tapers. This is the main circular piece of the fuselage, which is 4.32 inches in diameter and is jointed at uniform distances apart from each other to a spar made of two 1/8-inch sheet pieces of balsa glued together. There are 4 spars, as you can see, and they will be glued to the fuselage pieces when it is built. So far, I've designed the main part of the fuselage in the nose, which mounts the motor and propeller, as you can see here. I'll get into that in a few seconds. If you're wondering how the plane will fly when it looks like this, the skeleton of the plane will be covered with heat shrink RC aircraft wrap, which is light and allows for no air to travel through the skeleton structure. There's a hole in the main part of the fuselage, as you can see here, for all the electronics to be mounted. Let's talk about the nose. As I mentioned, the nose tapers down like on commercial aircrafts, but what's the reason behind this? The goal of an aircraft is, well, to fly, but how can this be done efficiently? By minimizing the aerodynamic drag. The noses of aircraft are tapered down to minimize the amount of drag from the air when in flight. Each nose piece tapers down by 1/4 of an inch on this plane, each piece, starting with 3.872 inch diameter and ending with 2.622 inch diameter. When designing the nose, there was a problem. How can the nose taper down if the original spars, as you can see here, are so wide apart? The nose wouldn't be able to taper down if the main spars were used as support. See? The solution to this problem was to add different spars that would connect the transitional pieces to reduce the distance from the center of the fuselage pieces to the spars so that the nose could taper down. As you can see here, there are 2 transitional pieces. They're attached to the main fuselage spars as well as the 4 nose spars. Another function of the nose is to house the motor. As you can see here, there are holes in the nose pieces which the motor fits in, and a piece that holds the motor in place and will be glued to the spars. The continuation of the holes in the nose pieces after the motor are to allow for the motor wires to connect to the rest of the electronics in the main part of the fuselage. Attaching the wings to the fuselage was one of the most challenging parts of designing the fuselage because it's such a vital part of the structural stability of the plane. My idea was to allow for the most surface area for the wings to be glued to the fuselage. This was accomplished by creating a part that attaches to the wing spars and modifying 2 fuselage pieces so that they can be glued directly to the wings. This was the piece I designed, which is composed of 18 1/8-inch thick pieces of balsa wood glued together to create a mount for the wings. The piece was designed so that the angle of attack of the wings is around 5 to 6 degrees when they're glued to this piece. The wing mount piece is mounted to the fuselage, as you can see here. And here's the full plane assembly, which I'm very proud of so far, which shows the wings and how they attach to the fuselage. As you can see here, they're glued directly to that piece. And here from above. Also, as I mentioned, as you can see here, there are pieces that I modified on the fuselage that allows them to be glued directly to the first airfoil piece because they're flush when the wings are mounted in position. Now onto the electronics. So far I have 2 servo motors, 1 brushless motor that will spin the propeller, 2 propellers, and an electronic speed controller for the motor. I need 3 more mini servo motors to control the flaps, ailerons, and elevator, as well as a battery to power all of the electronics. I also have a 6-channel wireless transmitter and receiver that I will use to control the plane. I have decided not to make a rudder for my plane, but instead only have a vertical stabilizer. This is because there are only 6 channels on the receiver and I already have 6 control systems. This is what I've completed so far, but there are a few next steps I will implement before my next video. Firstly, I will design the vertical stabilizer, horizontal stabilizer, and elevator. I will wire all of the electronics together and test them with the transmitter and receiver. And lastly, I will hopefully test my airfoil in a wind tunnel and start creating laser cutting templates. If you're wondering what computer-aided design software I'm using, it's called Fusion 360 and it's available free for students. I have always loved engineering, and when I was younger, I didn't have a place to start. By making these videos and following my passion, I hope to inspire you all and give you a place to start if your passion is engineering too. Thank you all for watching, and if you enjoyed this video, please consider subscribing. Have a lovely day.